Hello everyone, I hope you all are good and you all are practicing problems. Let us for now look at this one. And what is said in here, equipotential lines arising from a static charge distribution has been shown in a certain region of space. So यहाँ पे जो lines दिख रहे हैं ना, curved lines, these are basically equipotential lines. Equipotential lines कहने का मतलब, suppose कर लो आप इस line को choose करो, then at each point on this line, potential is going to be same. So यहाँ भी 70 volt, यहाँ भी 70 and so on. Done it? Now what we are asked to do, draw the electric field lines starting from point A. So अगर हमें equipotential surface दिया हो, तो इलेक्ट्रिक फील्ड हम कैसे ड्रॉ कर सकते हैं? सबसे पहला इंफॉर्मेशन ये होता है कि इलेक्ट्रिक फील्ड वेक्टर इज बेसिकली परपेंडिकुलर टू इक्विपोटेंशियल सरफेस और इक्विपोटेंशियल लाइन. ठीक है? सो सपोज कर लो आपके पास ये कुछ ऐसा सरफेस है and this is equipotential. Then let us take 2 points. This is point 1 and this is point 2. We are moving a charge, a small charge q from point 1 to 2. What will be the work done? So work done आप क्या लिखोगे? If we are taking this charge slowly from 1 point to 2, then you will say that is equal to q into delta v. Delta v is what? Potential difference. And I'm saying this is an equipotential surface. So delta v is 0, right? So work done has to be 0. It means there is no force basically operating on this charge throughout the trajectory, right? और अगर मैं यहाँ पे बोलूँ कि सपोज कर लो इस पॉइंट पे इलेक्ट्रिक फील्ड कुछ ऐसा है, in that case electric field will have component parallel to the surface and another component perpendicular to the surface. So if electric field has a component parallel to the surface, then this E parallel will apply a force on the Q charge, and in that case, work done to move this charge from point 1 and 2 won't be 0, right? Because there is force acting. So work done cannot be 0. But according to the definition of equipotential surface, work done has to be 0. It means what? It means E parallel has to be 0. It means what? Electric field has to be perpendicular to equipotential surface. So अगर आपको equipotential surface दिया है ना, then at each point electric field is what? Perpendicular. This is the first information. Second thing which is required is, अब यहाँ पे perpendicular आप दो direction में बना सकते हो, इस direction में and इधर down या up ऐसा. कौन सा लेना होगा? सो सेकेंड थिंग इज दैट इलेक्ट्रिक फील्ड बेसिकली का डायरेक्शन उस डायरेक्शन में होता है इन विच पोटेंशियल डिक्रीजेस द मैक्सिमम. So the direction in which potential decreases the maximum is the direction of electric field. ये कहाँ से आ रहा है? जैसे आपने एक फॉर्मूला पढ़ा होगा, माइनस ऑफ ई डॉट डी एल इज इक्वल टू डीवी. ठीक है? सो तुम्हारा डीवी, आई मीन अगर इसको आप लिखो ई डॉट डी एल इज इक्वल टू माइनस डीवी. सो माइनस डीवी का वैल्यू मैक्सिमम कब होगा? व्हेन ई एंड डीएल, basically when E dot dl is maximum. So this will be maximum when angle between these two is 0 degree. That is dl, that is displacement vector, is in the direction of electric field. यानी कि आप electric field के direction में चल रहे हो. So when you move in the direction of electric field, negative of change in potential is the maximum. So potential decreases the maximum. It's not increasing, it is decreasing basically. ठीक है? So because this is dv, okay, this is change and this change is positive and there is a negative sign over here. So negative of this change, this is maximum. Yani ki potential is decreasing the maximum. Okay, so in the direction of electric field, potential decreases the maximum. और यहाँ पे अगर आप ध्यान से देखो, this has a potential of 90, this has a 80 and this has 70. So potential is decreasing somewhat in this sense, right? In this direction. डन है. सो इलेक्ट्रिक फील्ड आप कैसे ड्रॉ करोगे? यू हैव टू कीप टू थिंग्स इन माइंड, फर्स्ट एंड सेकेंड. सो इलेक्ट्रिक फील्ड विल लुक समवॉट, इट विल लुक कर्व्ड. ठीक है? एंड इट each point on the equipotential surface, electric field direction has to be what? Perpendicular to the surface. ये आपको हमेशा याद रखना है, इससे perpendicular. ठीक है? So you have to maintain this thing and you have to मेंटेन सेकेंड थिंग. सो सेकेंड पॉइंट ऑलरेडी मेंटेन्ड है. इलेक्ट्रिक फील्ड का डायरेक्शन हमने ऐसा दिया, इन द डायरेक्शन इन विच पोटेंशियल इज डिक्रीजिंग द मैक्सिमम. Okay, so it is sorted. Now, if a charge is released at A, will it move along the field line passing through A? So कह रहा है कि अगर आप A पे एक चार्ज को रिलीज करते हो, so we know that if there is a positive charge, force on it will act in the direction of electric field. At this point, force electric field is in this direction, so force will act in this direction, right? And because of that force, it will gain a velocity. Done it? So it will have velocity in this direction after certain time. And we know that electric field here is not along a straight line. It is a curved line, right? So at each point, acceleration direction is going to differ. Done it? And then we cannot say that this charge particle is moving along the electric field line. क्योंकि देखो charge particle उस direction में जाएगा जिस direction में उसकी velocity होगी, not जिस direction में उसकी acceleration होगी. जैसे आप एक ball को ऊपर फेंकते हो, then velocity is in upward direction, acceleration is in downward direction, right? So basically motion का direction gets guided by velocity. And at the top point, when velocity becomes zero, then it is helpless. After that, acceleration acts in the downward direction. That provides it with downward velocity. And because of downward velocity, it starts moving in the downward sense. So basically, direction of motion will depend on ki velocity ka direction ki tarah. And velocity ka direction at each point won't be in the direction of electric field, right? It will be acceleration direction, not velocity direction. So we cannot say here चार्ज अगर ए पॉइंट पे आप रिलीज करते हो, इट विल नॉट मूव अलोंग द फील्ड लाइन पासिंग थ्रू ए. सो ए से पास करता हुआ जो फील्ड लाइन का डायरेक्शन है उसके अलोंग वो नहीं मूव करेगा. वी कैन नॉट से दैट. ओके, नाउ सी पॉइंट पे आप आ जाओ. हाउ मच वर्क इज डन बाय द इलेक्ट्रिक फोर्स इफ अ चार्ज मूव्स फ्रॉम बी टू सी. अब बी से सी तक चार्ज मूव करेगा तो वर्क डन जीरो ही होगा. वी हैव ऑलरेडी एक्सप्लेन्ड इट ओवर हियर. सो डेल्टा वी इज जीरो, सो वर्क डन इज व्हाट? That is also zero. Is the knowledge of path important in this calculation? No, because we are talking about electric field, conservative field. It will depends basically on initial and final point, and at both these points, B and C potential is same, difference is zero, and that is why work done is zero. So that is irrelevant. Okay. So I hope you have understood this question. यहाँ पे solve करने जैसा कुछ नहीं था. It was heavily based on concept, but still very simple and plain concepts. So I hope it is clear. But if you have any doubt anywhere, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.